Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Enolate stability is determined by the degree of charge delocalization. The more effectively the negative charge on the Carbanion carbon is delocalized into adjacent electron-withdrawing groups, especially carbonyl groups, the more stable the enolate. Step 1. Analyze enolate A. Enolate A is the dianion enolate derived from cyclohexane 1,3-dione or a 1,3-diketone pattern. The Carbanion, negatively charged carbon, is positioned between two carbonyl groups at adjacent carbons, C1, C2 and C6, C1 arrangement, i.e., C2 and C6 both bear C is equal to O. This means the negative charge at C1 can be delocalized into both flanking carbonyl groups simultaneously through resonance. Two carbonyl groups stabilize the negative charge, giving to resonance structures where the charge resides on oxygen. Step 2. Analyze enolate B. Enolate B has the Carbanion at C1 and the carbonyl group at C4, A1-4 relationship. The carbonyl at C4 is too far from the Carbanion at C1 for effective conjugation or resonance delocalization. The negative charge cannot be delocalized into the remote carbonyl group through the sigma framework. Therefore, B essentially behaves as a simple, unconjugated Carbanion with no significant stabilization from the carbonyl. Step 3. Compare. Enolate A has two adjacent carbonyl groups that both participate in resonance stabilization of the negative charge, dramatically lowering the energy of the enolate. Enolate B has no effective resonance stabilization because the carbonyl is too far away, 1,4 relationship, not conjugated. Therefore, A is far more stable than B. Step 4. Why other options fail? B. They do not have the same stability. A is doubly stabilized by resonance. B is not stabilized at all by its remote carbonyl. C. B cannot be more stable than A since B lacks resonance delocalization. D. A comparison can indeed be made based on resonance delocalization principles. Therefore, the correct answer is A. Therefore, the correct answer is option A.